Hello everyone, I'm Dr. Cerf, I'm your iFit guide, and we're by the Hudson River in New York City. We're gonna walk and talk about perception and our brain. Let's start. So, the one thing we need to understand about the brain is that the brain doesn't really see the world, it doesn't really hear the world, it doesn't really smell or feel the world in any way. The brain sits in a dark place, it's quiet, it's bony around it, and it's full of water, and all it knows about the world comes from our senses. And what we're learning is that the way we see the world is a little bit skewed towards what our senses give us. We don't really see the world as it is, we see a fraction of it, and we create it in our own minds. I want to tell you about an experiment that will lead us towards that. And I want you to remember that at the end of this journey, I'm going to give you the answer to some very important question, which is, why is sunset romantic? Okay, the experiment. So this experiment is a classical experiment talked a lot about in psychology studies. It's an experiment where you took two rats and you put them in a little tunnel. So they sit there and there's no way to escape other than to go on one or the other side. And the two rats sit there, and what happens typically when two rats like that, in experiment it's actually male rat, but it could be also female, they start fighting for dominance, and one of them tries to kick the other one out of the tunnel. So they start fighting, and presumably one of them is going to win. One rat is going to kick the other one, and it's going to control the tunnel. And what we learned from research on those rats is that when this happens, typically the rat who won, the one who actually kicked the other one out, is deemed the winner, and it's a winner forever. The one that lost, the one that was kicked out, is the loser, and it's a loser pretty much forever, statistically. As in, if you bring the same two rats tomorrow to the same tunnel and put them together, the winner is much more likely to win again. The loser to lose again. If you take the loser and put the loser against another rat, a different battle, it will still lose, because somehow the losing rat and the winning rat internalize that they're winners and losers, and they just take it with them forward. What's interesting here is that this is true not just if the rat that won is actually winning fairly, it's even true if it won unfairly. As in, if you take the two rats and you use a stick to push one of them, you give it more power so it wins by kicking the other one, not because of its own fault, but because of you giving it extra effort, it still thinks of itself as a winner, and it will keep winning by itself in the next battles, and the loser is the same. So something about our experiences changes our brain and makes us internalize a state. It thinks that we're winners and losers. I'll tell you a story about humans that kind of shows how far it can go, and then we're going to explain how we can actually use it in our own life. In a study that a colleague of mine ran that's interesting, they bring people to the lab and they have them play Monopoly. You all know Monopoly, the simple game where you have to kind of go around, buy houses and hotels and railroads and win the game. Two people come to the game, they are both going to play against each other, and as the game begins, the instructions are unfolding, and they're told, the two players, that one of them is going to be the rich player, the other one is going to be the poor player. So here's how it's going to go. Rich players get $2,000 right away, and poor only $200. Rich players get to throw the dice twice, so they actually get to walk much faster. Poor only once. Rich players start with 4 hotels already in their bag, poor with none, and when they pass through go every circle, the rich guy gets $2,000 extra and the poor only $200. So what happens quickly if you play this game is that the rich gets even richer and the poor starts losing more and more. Similar to the rats, if you can see where I'm going. Now here's the thing. To determine if you're going to be the winner, as in the rich guy, or the loser, as in the poor guy in this experiment, in the beginning we throw a dice, and whoever scores the highest gets to be the winner. The guy who starts with more money, the rich person. So the two players come, they don't know who's going to be the rich or the poor, they throw the dice, one of them wins, and he becomes the guy with the most money, and they start, and of course, unsurprising, the winner gets even more money and wins quickly more, and the loser loses more, and the game kind of usually ends with the gap being really, really big. What's surprising in this experiment is that soon after the experiment begins, the person who was luckily assigned to be the rich guy with a little bit more resources to begin with, internalizes that he is actually a winner, and he starts giving advice to the poor guy. He starts telling him, what you did, you should have actually bought this railroad, you would have done a better job if you did that or that. Giving advice to the other person, kind of telling him what to do. And not only that, the loser, the poor guy who's actually continuously losing all the things, also internalizes this and he says, I guess I made a mistake here, I should have done that or this. They kind of forget quickly that it was a random choice that assigned them to their roles, and they immediately internalize the state. So the message here that we're starting with is, in many ways, life throws things at us, and what our brain makes of them determines how we're going to move forward. It tells us a story that we're going to carry with us and explain a lot of our events, not because it's reality, it's because it is how our brain manifests reality in our own mind. So this raises the question, what is real? If our brain makes up stories and if events outside can change our mindset, is there anything that is real that we can cling to that say, okay, this is reality? Park this question, I'm going to answer that in a second. And before we do that, let's expand a little bit on what is unreal. So, the brain, as I said, doesn't really see the world as it is. Our brain experiences the world by sampling parts of it using our senses. And we have senses that you are familiar with. Vision through our eyes, audition through our ears. We can smell using our olfactory bulb. We have the smell of taste. We also have our skin, which is full of sensors of reality. We also have all kinds of senses that are less famous, like the sense of our body internally. We know exactly where things are in our body by just feeling them. Even if our eyes are closed, we know exactly where our legs and our hands. This is called proprioception. And other mini sensors, even the pain is regarded one. But the point I'm trying to make is that those sensors, those devices we use to capture the world, are not perfect. They only sample a fraction of what's out there. Let's look at our eyes, for example. Our eyes don't really see what's out there in full. They only capture 1/10,000,000th of the type of things that we can see. Our eyes see everything between the infrared and the ultraviolet spectra, but the electromagnetic spectrum is full of things that our eyes cannot capture. There are gamma rays and X-rays and microwaves and radio waves. All of those things are real. It's just that our eyes can't see them. And we know that they're real because we can actually build devices that sample them and capture them. Our cars have equipment that captures the radio waves and turn them into a sound that you can hear on your radios. Microwaves turn microwaves into something that moves molecules that allows us to heat our food. All of those things work, it's just that our eyes don't see them. In fact, right now, many of you who walk with me have probably in your pocket some cell phone that broadcasts into a cell tower nearby, and there's a ray that goes out of your pockets into this cell tower, and it's there, as in your phone can capture it, but you don't experience it. It's not part of your reality. Now here's the interesting thing. There are other animals in nature that actually have different sensors. And for these animals, reality is different. For example, bats have different types of eyes, the echolocating eyes. It's actually the ears from the best perspective, but let's call it the eyes, that sends signals that bounces back from walls or from objects, and that's how the rat or the bat actually figures out what is around it. If there was a bat right now in the gym where you're exercising, it might have flied in a different and weird pattern that goes around all kinds of rays of light that go from your cell tower to the phones in your pockets, because for the bat's perspective, this is reality. The bat sees things that you don't see, and it can fly among them. Birds have in their heads something that we call magnetometers, which are little sensors that figure out the magnetic fields of Earth. So birds, when they fly, they know exactly where north is all the time. That's how they fly and migrate around the world. And there are many other objects. Snakes, for instance, have eyes that sample the world in a different frequency, and it actually looks at the world as infrared colors. So a snake that looks at you doesn't really see you as you are, it just sees a blob of red and blue items around it. That's kind of how it is. Kind of like TSA sees people when they go through the machines. And there are many, many other animals in nature, all with different devices that are endowed to them by nature that sample different parts of the world. Now here's the interesting thing. The brains of all those animals work in the same way. The brain of a snake, the brain of a bat, the brain of a human, they're all made of little cells, we call them neurons, that speak a very specific language of electrical, chemical signals that go between them. And while the brain of a snake is smaller than yours, of course, and it's folded differently and it has different types of neurons, at the end of the day, it's pretty similar. So the only difference in why the rat or the snake or the bird see different experience of the world is because their eyes or ears or all kinds of devices that they use, magnetometers, turn the world into the language of their brain and make meaning out of it. So perception of reality happens in your mind. The eyes take a snapshot of what's out there, they turn it into the language of the brain, and then your brain makes meaning out of it and calls this seeing. And the interesting thing about that is that we know that there are some people who have different ways of experiencing the world, and we can actually see how their brain is wired differently than ours. There's a disorder called synesthesia, which is all about people having rewiring inside their head that makes them experience the world differently. For example, people with synesthesia might taste days of the week. When you speak about Wednesday, they feel like a taste of lemon in their mouth. When you speak about Monday, they have a bitter, salty experience in their mouth. Other people have synesthesia that maybe maps numbers into colors. When you say, I was walking and it was 6 p.m., they see yellow lights in their head. When you say it was 7 p.m., they see red lights. Somehow there's a mapping between light and colors into numbers in their brain. And there are many other versions of that. Some people, when they see movement, they hear sounds. And some people, when they change the temperature, they feel different things. The point is that the brain is rewired such that an experience coming from one sense turns into another. And people actually experience the world differently. Now, synesthesia is actually a disorder by which the brain is rewired, but we also know that we can manufacture that and make it work in people that don't have that. For example, people that are blind. People that are blind many times learn to read Braille code, so they kind of move their fingers around dotted surfaces, and they're supposed to make meaning out of them. When they first learn to interpret Braille, they kind of move their finger and they learn the code. It tells them if you see 2 dots, it feels like the letter A, and if you see 2 dots and a line, it feels like the letter B. And in the beginning, they have to do it cognitively. They have to kind of make meaning by thinking about it. But after a while, people that read Braille will tell you that they just move their fingers and the meaning just comes out. They don't really think about the dots and the lines, they just somehow feel the meaning. Similar to how you read and write. When you read and write, you don't really say, okay, there's a line and a line and a line, that's the letter O, now there's another one, line and line, that's the letter R. You just kind of move your eyes around it and the meaning comes to you. The brain does all of this part automatically for you. It takes information through the senses, processes it, and when you become aware of it, it's already wrapped in a form that is full of meaning. And this process, making meaning and learning how to take signal and turn it into something meaningful, is something that happens every time we learn new information. Fortunately for us, most of the life happens when we're babies, when we learn how to do that. So babies that are born don't know how to see, for example. Their eyes are blasted with all kinds of colors, and their brain has to learn how to map those colors into the world that we call reality. So first, as a baby, you kind of see shadows and your eyes are blasted with information and your brain doesn't know what to do with it. It gets blasted with all kinds of photons that have color in them. But after a while, your brain gets used to seeing, for instance, some colors coming always before food arrives, and some movements happening just before someone tickles you. And over time, within months, your brain learns to make meaning out of those signals. It learns to see. No one teaches the baby how to see by telling it, no, baby, you need to take the pink electromagnetic light and put it on this neuron, and then wait for other neurons to come, and then together combine them into a shape. And if the shape is moving towards you and getting bigger, it's something that moves towards you versus away from you. None of us are learning the world by that. We just experience reality, and our brain solves this problem for us. And this is why it's important. It's important because this means that the brain that we were born with has this magical ability to get signals without anyone telling us what they mean and coming up with some order in them. It takes us a few months to come up with a meaning for signals that arrive at us. This is how we learn to see, to hear, to smell without anyone giving us instructions. And because this is true, we can do something remarkable. We can actually enhance the brain by using this power that it has to train it to do more things than the ones that we were born with. What we're calling in science human version 2.0, enhancing human abilities. Let me start by telling you what we can do right now and where it's going. Right now, we can take people who lost senses and give those back to them. For example, if you lost your hearing at some point because your ears are not functioning well, you used to hear, your brain knows how to take signals from the ears and make meaning out of them and calls it sound. But at some point in your life, you lost the ability to do that. Your ears don't know how to take molecular compressions and make them into the signal of the brain, and you become deaf. We can help you. The way we do that is we can build devices, we call them the cochlear implants, which we put just right where your ears is, and we make them work such that they do the same thing that the ear does. They sample the world and take molecular vibrations, and on the other side, turn them straight into electrical signal that goes into the brain. Now, importantly, the way the implant works is not the way the ear works one-to-one. As in, the ears touched part of the brain that the cochlear implant does not. And when people built it on the first place, they didn't really believe it's going to work because we knew that we don't know how the brain works perfectly. But what we learned is that the brain does the work for us. Remember I told you that the brain is amazing in finding meaning in signals? What the people who built the cochlear implant learned, we blast the brain with signal that comes from the same kind of similar pattern, but not the same exactly, and we give the brain time to figure out the meaning. And this is how the brain, within say 7 months of practice, learns to hear even if you lost your hearing at some point. Your brain learns to interpret the signal from the cochlear implant and make meaning out of it. So a person who was deaf after about 7 months of being blasted with new signal learns to hear again. We can restore hearing for deaf people. Similarly, recently, neuroscientists have played with retinal implants. Same idea. A person who lost his sight because the eyes don't work anymore can be implanted with a device that sits where the eyes are, samples the world and turns it into the language of the brain, and lets the brain do its magic in finding meaning in the signal, so that after a few months of doing that, a person who was blind starts saying, you know, I start seeing shades and movements and colors, and before long, we can restore sight to the blind. Now, these are all examples of how neuroscientists are right now taking senses that were lost and returning those senses to full function. With animals, we're playing right now with experiments that actually restore not just sight and audition, but also full motion and full movement. So some people who were injured in accidents, for example, may have lost the connection between their brain and their limbs, and they're effectively paraplegic. They can't move. They sit in a wheelchair and they can't control their legs, let's say. In principle, the legs still work. They still have muscles, they still operate. It's just that there's no connection between the brain and the legs that can activate them. So what neuroscientists are playing with right now are experiments where we actually put devices in the brain of those patients that read the brain activity that controls the legs. And when we know that the brain intends to move the leg, we send a signal straight to the leg that activates the leg and makes the person walk. If this will work out perfectly, this means that we can actually restore walking to people who lost the ability to walk. Soldiers who come back from war and were injured and are in a wheelchair could regain the ability to move just because the brain is still operating and we can read the brain activity that intends to control the movement and make it work again. Now here's where it becomes really, really cool. Not only can we restore lost senses, we can also increase your abilities, as in give you senses that you did not have before. An example that kind of paved the road to that happened in 2011, where a study was done on apes. Those were apes in a lab that had full body work and were part of an experiment that was trying to see if we can actually read the brain activity that controls their limbs and teach machines to operate for them. So in the experiment, we had a monkey. The monkey was sitting there, and someone tied the monkey's right arm behind its back, so it can't move it, and put a robotic arm just where the arm would be. The robotic arm is connected to the monkey's brain directly, and when the experimenter came to the room and put a marshmallow in front of the monkey wanted to reach and grasp the marshmallow with its hand, but the hand was tied, so it couldn't do it. But it thought the thoughts that would move the hand towards the marshmallow. And what happened was that the thoughts were read from the monkey's brain, controlled the robotic arm, and the robotic arm reached out to the marshmallow and grabbed it for the monkey. So the monkey sat there, thought, gee, I wish I could get this marshmallow, and this thought led to a robotic arm grabbing the marshmallow and feeding it. The monkey was surprised. He just thought about something and it happened. Try again, another marshmallow is there. The monkey again thinks, I want to grab this marshmallow, and the robotic arm just does the operation for it and feeds it. For the next couple of hours, the monkey gets used to just thinking about grabbing marshmallows and having a robotic arm do it for it. Seems perfect. This was the experiment from the perspective of the scientist. They wanted to show that we can actually read the brain activity of an animal, control a robotic arm, and help the animal feed itself using external devices. What they didn't anticipate is what happened after the experiment was over. The experiment is over, they untie the monkey's right arm and they let it go, and they think, okay, the monkey is going to just go back to using the arm the way it used to before. And that's when the surprise happened. Another marshmallow is placed in front of the monkey, and it still uses the same part of the brain that was made by nature to control its own biological arm to grab the marshmallow. But this part somehow controls the robotic arm that grabs the marshmallow, whereas the monkey can use his own arm to scratch its head. So effectively, the monkey learned in the course of a few hours to reallocate the part that controls the arm, the biological arm, in his own brain and repurpose it for something else. So effectively, it can scratch its head with the hand that used to be controlled by the brain and use the same brain to now control a robotic arm. The monkey basically got a third arm. It has its two biological arms and a third one is in control with the same brain. Somehow the brain regained more access. Once this was shown, we realized that we can actually enhance humans and not just give us back, say, the sight we had before or the ability to hear that we had before, but actually improve them. So the idea of Human 2.0 is that we can actually do the same thing that the monkey does with humans. We can take the eyes of the snake, plug them into the brain of a human, and wait, let the brain do its magic and find meaning in the signal coming from the eyes of the snake, and before long, we're going to have a human who can see infrared. Or take the echolocating eyes of the bat, plug those into the brain of a human, let the auditory cortex, the part of the brain that parses sound in humans, work its magic, and within 7 months, we learn to hear more of the world. We learn to see light, but also, for instance, hear things bouncing from the world and know that there's something coming from far ahead just because we're gonna hear it farther than our normal ears work. The idea is that there's now no limit to what we can do as long as we think of our brain as a sponge that can get signals and find meaning in them. A colleague of mine uses the analogy of a Mr. Potato Head. It says there's the brain, and you can plug all kinds of things like ears and noses and multiple mouths and so on, and the brain is going to find out how to work it and make meaning out of it. And with this in mind, you can really let your imagination go as far as you want. You can think of people who get better limbs so they can run faster, or if you're working as a mover and you need much stronger arms that allow you to lift pianos, we can just give you one extra arm that speaks to your brain has to control it, and you can suddenly lift pianos with one arm easily. Or even build wings that you can put on your back, plug it to your brain, and teach people how to fly. Everything that we know how to build and we know how to control can become a tool that we can now plug into the brain and let the brain find meaning in it. Now, this is not just science fiction. There are some mini experiments that show evidence how we can repurpose senses to solve problems for us. For example, a colleague of mine showed that we can actually solve problems by letting the brains do the thing that it's made for, which is find meaning in complex data that seems to us unstructured. Here's what I mean by that. In the experiment that my colleague did, he brought people to the lab and he put a vest, it looks kind of like my shirt, on them. So they wear this vest, it's tight, attached to their body, and it has all kinds of motors on it that can vibrate and press on the body. The person sits there in the lab, and then the vest is turned on, and she feels maybe some pressure on her left side and some movement in her belly. Then the vest is turned off, and on a screen in front of her, she sees 2 arrows, and she gets asked the question, for this feeling that you just had, what's the right answer? To go left or to go right? And she says, I have no idea. It's just a feeling in my body. Then we tell her, you know what, just guess. If you don't know, just make a guess. She says, okay, I'm guessing that I should go left. And then she gets feedback that tells her, correct, this was the right choice. For the feeling just head, left shoulder, right belly, the correct answer was to go left. Let's try again. The vest is turned on again, and this time she feels movement in the chest and something in her lower back, and again 2 arrows appear with a question. For this feeling, what's the right answer, left or right? This time she says, I think that this time it's right. And she gets feedback again, telling her if she was correct or incorrect. She does this again and again and again for, say, 1 hour. For 1 hour, she feels things, makes decisions, and gets feedback on whether she was correct or incorrect. And what we learned from this experiment is that over time, she gets better. As in the beginning, she has no idea. She just guesses. She just kind of feels things and says left, right, without knowing anything. She just wins and loses in every trial. But after a while, she starts figuring out the pattern here. She says, every time I feel something in my left side, I should go left, and in my belly, I should go right. And she starts doing better than just guessing. She starts constantly feeling things and making the right choices, left, right, correctly. And the interesting part here is that the pattern that she feels in her body isn't just random. It's not just random movements of motors. It's actually real data that was fed into the vest, and what she does is makes real life decisions. In the example I told you right now, what she felt was the stock market, the S&P 500. Someone took the stock exchange and turned it into a feeling in their body, and she felt all kinds of movements of stocks, and what she decided was whether to buy or sell those. Now, she didn't know any of that, but what she learned over time is somehow to feel the market in her body and to decide if she should buy or sell stocks, and she does it better than just guessing. She somehow learns how to trade in the market just by feeling it. And in that sense, we can do a lot of things with her. We can take information about her car, and instead of having dials that tell her if the car is running out of gas or what's the speed, she can just feel it and learn to feel the traffic. Or maybe if she works in a factory with a lot of people working around and she needs to get a lot of access to the assembly line, instead of looking around and kind of looking with her eyes to see where everyone is, she can just feel the entire factory in her body, and somehow her brain's gonna make meaning out of it, and she would know if there's too many things happening there that she needs to attend to and too few there. The idea is that the brain is magical in finding signal in complex data, and if we can just harness this power, we can help ourselves find meaning in complex things that otherwise are really hard for us to interpret. And this is where I'm going to close the loop about perception and tell you the following. Perception is our brain ability to take all these data from the entire world and make them into a coherent story. To take the light that our eyes see, the sounds that our ears capture, the smells, all of them combined is what we call reality. It's not the full story. There are more things out there, but it's the best our brain can do. And with that, we can actually see the richness of the world around us and find beauty in what our eyes, ears, nose, tongue, skin can give us. And I wanted to tell you that because once we know that, we can start appreciating how beautiful is the ability of the brain to find meaning in those things and give us experiences that are rich. And I'm gonna use one that I love to tell you how it's happening in the brain and why it's key. And that's the sunset. As you all see, the sun is setting next to us right now. And somehow, a lot of times, humans refer to sunset as a romantic thing. And today I'm going to tell you that a lot of it is actually neuroscience. And here is how. If you look at the human eye is kind of like built like a lens. It has two muscles, one at the top and one at the bottom, that control the lens's movement, and they make it either flat or very round. When the lens is very round, the muscles work very hard to push it and keep it as a circle. The focus is nearby, and you can read from a close distance. So if you're looking at a book, for instance, and reading it from a very close distance, it means that the muscles of your eyes are working very, very hard to keep the focus nearby, so you can make it clear and see things that are very close. If you look far away, the muscles are relaxed, the lens is pretty much flat, focus is far away, and you can actually see things in the horizon. As babies, we learn quickly how to move the lens as we move our eyes. So if you look right now at me from nearby and I'm totally in focus, it's because your eyes adjusted perfectly the lens so you can see me. If you look for a second away and back to me, nothing was blurry for a second, because once you moved your eyes, once you saccade, your brain told the eyes we're going to go look at the far horizon, and the eyes immediately adjusted the lens to make sure that everything is perfectly in focus even there. So the brain and the eye have this contract that when the eyes move somewhere, they immediately know how to correct such that things would look perfect. Why am I telling you all of that? Because there's another contract that goes the other direction, where the eyes tell the brain to help them make the world easy. For example, if you read this book from very close distance for, say, 5 minutes, your muscles have to work very, very hard to keep the focus nearby. It's pretty tiring. After a few minutes, they're going to ask the brain, hey brain, we're working very, very hard to keep the focus very, very kind of close. Can you help us and make it so that we don't have to work that hard? And the brain typically would say, sure, I'll do it for you. And if it doesn't, if you keep doing it, despite the fact that it's getting quickly tiring, your brain is going to give you a headache. This headache is your brain's way of telling you, hey person, you're forcing us eyes to do something very, very intense for a while. We need a break, stop it. So the headache you feel when you read a book from nearby for too long is your eye-brain contract telling you, please stop doing that. In the other way, if you look far away, your lenses are very, very relaxed, and the brain feels that it's supposed to fall asleep. Why is that? Because for the most part, our lenses are stationary and out of focus, not moving, only when we try to actually fall asleep. When we close our eyes, the lens becomes very, very relaxed, the muscles don't work at all, and that's the signal to our brain to release all the hormones that help it fall asleep. When the muscles don't move for a while, the brain tells itself, okay, it's time to relax, I'm gonna go and quiet it down and fall asleep. Now there are some moments, very rare, when we actually keep the lens not moving and the focus far away, even though we don't want to fall asleep. One of them is when you look at the sunset. So if you and your partner, let's say, go sit together by the pier and look at the sunset and keep your eyes focused on it for, say, 5 minutes. The lens is stationary, focus is far away, the muscles don't move, you tell the brain, we're very relaxed, I guess the person who's containing us wants to fall asleep. Please, brain, release all the hormones and all the nutrients that make us feel calm and relaxed. And the brain does that, and after about 5 minutes of sitting and looking at the horizon, you actually feel good in your body, relaxed and peaceful, and you say, I'm feeling this unique thing that I didn't feel before. I guess my partner is really, really charming. I really like them. That's why I feel so beautiful and joy right now. And you attribute this experience of joy that your brain created to your partner. That's what romance is. Your brain taking experiences and turning them into a feeling. So next time your partner takes you to see the sunset and you feel good about them, know that it's actually not them. It's your own brain creating the perception of you enjoying the experience. Now you still have to choose to go with them, so there's still something about them that made you choose to go to the experience. But in a way, what it teaches us is that a lot of things that we feel are reality are just our brain's way of making meaning and giving us feelings that will give us joy. So the pain you're feeling right now after walking for 30 minutes, if you're getting tired, is in your brain. The beauty you feel when you look at the sunset is in your brain. Most of the world is in our brain. And as we're learning, the more we understand about how the brain creates those, the easier it is for us to control it and give ourselves some access to the experiences that allows us to have more abilities to make them our own and make it such that we are the ones controlling them rather than they controlling us. I hope this was helpful in understanding perception. Thank you for joining me in this journey. I am Dr. Cerf, your iFit guide, and this was a journey in perception into the sunset. Thank you. Hello, I'm Professor Cerf. I'm your iFit guide, and today we're about to cross the Brooklyn Bridge and talk about decision making and your brain. Let's start our journey.